All right, welcome everyone to today's webinar. We see that there's still a number of people still logging into the system, so we're going to give everyone about another minute or so before we get started. Thank you. All right, let's go ahead and kick things off here. So good morning, good afternoon, or good evening to you. And welcome to today's webinar, Vivian Health Improves Job Seeker Experience with Real-Time Analytics. I'm Andrew Yeung, Senior Director of Product Marketing here at Materialize. And we are really excited to have Max Calehuff here joining us today for our webinar. Max is Senior Data Engineer at Vivian Health. And before we get started with our content today, just a few housekeeping notes. So this session is being recorded, and we will be sending out our recording shortly after the session, probably the next day or so. Everyone attending here is in listen-only mode, but of course, if you do have any questions, feel free to enter those questions and type them into the chat. A colleague of mine is actually monitoring the chat window, and he will be able to respond to the questions that you have. If we don't get to those questions, we will do our best to get to those at the end of the session during Q&A. So in terms of the content that we're going to cover today, we're going to talk a little bit about Vivian Health, who they are and what they do. But more importantly, Vivian Health is actually leveraging real-time data. And so we want to get into the use cases. And Max is going to talk through how they're leveraging real-time data for their particular use case on routing leads to their particular recruiters. He's also going to talk to you about some of the implementation mechanisms that they've attempted in the past, some of the challenges that they've had with respect to batch updates when they're trying to handle real-time transactional data. And then we're going to go into what they have actually done since they've actually implemented Materialize to help them go from batch to streaming. So with that, Max, I'm going to hand this off to you, and why don't you introduce yourself and also give the audience here an overview of Vivian Health, the work that you do there, and then we'll go straight into the use case.
Thank you, Andrew. My name's Maxwell Calehuff. I'm a data engineer at Vivian Health. I'm basically responsible for overseeing all of the infrastructure that supports the data team and beyond. We have also served a lot of data to the app and do analytics, machine learning, that kind of thing. A little bit about Vivian Health. They were founded in 2017 out of San Francisco. Vivian is a tool that helps connect travel nurses and other healthcare professionals with employers across the country. Our goal is to pair these nurses and other workers with competitive, high-paying healthcare jobs. And we leverage a lot of intelligent matching and deduping efforts to try and bring transparent information about and consistent information about a wide selection of job opportunities. And our goal is to provide the most accurate information about the best paying jobs to the most number of people. And this is some of our customers right now are IDR Healthcare, Accent Care, and Premier Medical Staffing. Yeah, these are some statistics on Vivian. Currently, we account for 15% of travel nurse placements in the U.S. And we've been growing pretty quickly. We already have 270 unique employers. Already 4.4 million apps submitted on the platform, although that's that's got up since I believe we pulled these numbers. We've had a lot of revenue growth and user growth. We're really proud of what we've been able to accomplish. And data's been a really big part of that. So this one of our I talked about this a little bit earlier, but one of the most important things about running a platform like this, which is trying to like solve complicated matching problems between nurses who might have disparate certifications and levels of experience and like preferences on where they want to work if they're going to open to travel. So we work with recruiters who are able to try and confirm whether or not these nurses are a good fit for certain jobs. And we give recruiters who are, we try and give recruiters who perform well and give the best user experiences more leads on potential nurses who are looking for jobs. And so one of the ways we do this is by analyzing how well recruiters respond to applications that are sent by nurses. And so in order to do that, we need to know like if a nurse like sends out an application, which is a lead that got routed to the recruiter, did the recruiter respond within a timely fashion, and is this recruiter like leaving a bunch of outstanding applications unresponded to? Yeah, so this is just a brief overview of how we calculate this. And we have these applications which are like basically conducted through a chat service that get updated in real time. But before we implemented streaming with Materialize, we could not update this application response rate in real time. It was being calculated in batch, and you could theoretically have like up to an hour delay on this rate being updated. Next slide. Yeah, so this is a diagram of what was happening. So we had like a P-SQL database that was getting updated with all these messages that were occurring in our app. Then every hour we would batch load like a snapshot of this to Snowflake, do transformations on it in TBT, get these metrics about the recruiters, specifically what their application response rate was, and then load it via Airflow into DynamoDB, and then we had a Lambda endpoint that the recruiting app would use to would hit to get this number. And then depending on how well a recruiter had responded, if they were above a certain threshold, they would get new leads. So this introduced a problem though, because theoretically, like if a recruiter logs in just after these DBT models have been created, they could have to wait up and then respond to all their messages. They could have to wait up to an hour to get more leads. So we got a lot of complaints from recruiters about this. So these are some like our initial attempts at implementing streaming. First thing we tried to do is like use Debezium to capture the chat message events directly from Postgres, and then pipe these into Flink and have a Lambda endpoint on top of Flink that would serve things to the recruiting app. This like introduced it was hard to get this working reliably, and the complexity like quickly became like untenable. We found out a way to where it actually did work, where we could use segment events instead of and a kinesis pipeline in order to capture these events consistently and get this like response rate updating in Flink and served via Lambda. The issue with that is that it required us to introduce Scala into our code base, and because we're a data team, we're primarily working in Python and SQL. There were only like 2 people on our team who would really be able to like work in Scala if something went wrong. And if we wanted to because Vivian's growing, and if we're going to hire new people in the future, making that a requirement also can narrow our candidate pool. So we really wanted to go with a simpler approach that was more similar to our previous implementation. Yeah.
All right. Well, thank you for that background, Max. Before we go into the actual implementation with Materialize, I did want to spend a few minutes to give everyone an overview of Materialize. And so for those of you who are unfamiliar with Materialize, we are the operational data warehouse. And so as a company, we were founded back in 2019, and our founders and our leaders, brought with them, fantastic, background and DNA in databases, data streaming, data warehousing, and so forth from companies like Cockroach Labs, Microsoft Research, Apache Flink, Confluent, and so on. Our product is built on top of a computational framework known as a differential and timely data flow. Our co-founder, Frank Masheri, while at Microsoft Research, he actually published a paper about this computational model, which provides a way to incrementally maintain results at sub-second latency. And so by doing so, what we were able to build is essentially a data warehouse with a streaming engine built in, so that it can handle real-time data at really low latencies, and also handle incremental updates to that data and be able to serve those into updated views to their downstream clients. On the right-hand side here on this slide, just real quick, in addition to Vivian Health, we're really happy and proud to serve some of the most innovative leaders in companies in their respective industries who are looking to use real-time data to help drive their day-to-day operational workloads. And at the bottom here, we're backed by the likes of Lightspeed, Kleiner Perkins, Redpoint Ventures, and we have raised $100 million to date. And so, when I talk about operational workloads, what does that actually mean? How do we differentiate operational versus analytical work? And so when we think of analytical work, or the tools to support analytical work, we usually think of things like, business intelligence or ad hoc exploratory analysis or dashboards and KPIs and such. These are working off of analysis of historical data, which can ultimately help drive longer term business strategy, right? Now, on the other end of the spectrum here, operational work would be things like, alerts, notifications when a particular item dropped below an inventory threshold, or data that needs to trigger automation or workflows, or real-time views into how an application would be personalized based on what you have accomplished, right? So this is really relying on the most up to the second, the freshest data that you have, and so the fresher the data, the more optimally you can react to that and make decisions based on that data. And so because of these differing needs, when we think of a analytical data warehouse or a traditional data warehouse, that's typically optimized for more of those analytical workloads. And in order to handle more of the operational work, businesses and companies like Vivian, they have tried to rely on batching, as Max had mentioned, to get more frequent updates to the data, or to also try to build a system using stream processing. And neither one of those approaches we've seen have worked out very well, at least not very optimally. And as Max had mentioned, building a system using stream processing certainly requires a lot of resources with expertise. Oftentimes in smaller teams, you're just not going to have that kind of expertise, and it gets complicated very quickly. And if you are batching your data warehouse updates, ultimately you still can't really achieve the low latency without incurring the cost of constantly updating your data warehouse. So what Materialize had done was we set out to build an operational data warehouse, and so our vision has always been to combine the ease of use of a data warehouse with the speed of streaming, and so within your own ecosystem and stack, the Materialize is able to connect to upstream data sources from databases like PostgreSQL, MySQL, or event streams coming from Confluent or Kafka, or even application data using webhooks. It's also able to serve up the freshest data to the downstream applications that's trying to access all of that data live. Now, when we think of our North Star for Materialize, we think of these, three key product principles here. And this is really how we've designed and implemented our operational data warehouse, is really around freshness, responsiveness, and consistency. And so, freshness, that's pretty obvious, right? As soon as new data arrives or the data is updated, we will Materialize will be able to serve up, the most up-to-date data. And then on the responsiveness side, you want to be able to easily interact with your data. At Vivian Health, they had this recruiting app, and they want to access, the incoming message stream and use that to calculate the application response rates, right? And so, how do you interact with, all of the latest data that's coming in a simple manner with things like, operating with SQL. And then, of course, there's also consistency. By consistency, we're referring to strong transactional consistency, not eventual consistency. So as you're creating views on top of data that's constantly updating across all of your transactions, you make sure that you're getting views that has the correct data immediately. And so, Materialize, again, these are our core principles. And so, we handle all three areas, and, a lot of the different approaches, whether you're using stream processor or analytical data warehouse, they can at most really address only two of these. And for us, we believe, to be able to handle, operational work, you really need all three of these. And so before I hand this back off to Max to talk a little bit more about his implementation experience with Materialize, just some of the key capabilities that we offer here. First off, obviously streaming inputs, being able to connect to your CDC sources like Postgres, MySQL, event streaming from Kafka, Confluent, Redpanda, and also upstream applications using webhooks. It's also PostgreSQL wire compatible, so you can reuse your existing SQL business logic that you've been using for your data warehouses. So it's very easy to connect to those and also port that logic over. Incrementally maintain views, writing queries up front with complex SQL transformations and complex joins, multi-way joins, what have you. These views that you had defined will incrementally update as soon as new data arrives. And support for DBT. Again, this was very critical for customers like Vivian. For them to be able to use existing DBT models to be able to transform incoming data, streaming data in real time. And then we also have a capability to subscribe to these real-time updates. So as soon as data in a source or a table or a view is updated, your subscription will basically inform you of the latest data that has been updated. And then the syncs, being able to leverage your real-time data in external applications, being able to query them from applications, from dashboards, or being able to write to those external downstream systems to applications like Census, or even write it back to streams like Redpanda or Kafka. And peeling this back just a little bit here, under the hood, Materialize does work differently from a traditional analytical data warehouse. On the left, traditional database engines, the work is typically done on the reads. And so this limits the end-to-end latency. And so the more you want to access the most updated data, the more you want to, read. And so the more work the database, the data warehouse needs to do. And this becomes a lot more costly. Now, on the right-hand side, we do things a little differently. We have a built-in stream processor. And so as you define those real-time updated views that are going to be incrementally updated, the downstream clients that actually performing the reads on the data, it's essentially only reading the increments, and so computationally it's able to get access to the most recent data almost instantly with essentially computationally free access. So with that, Max, let me hand this back off to you, so you can kind of talk to the audience about how you implemented Materialize and your experience with that.
Thank you so much, Andrew. Yeah, so if you look on the right, you can see a diagram of what our current stack with Materialize looks like. We load changes in the Postgres table, namely message updates, directly into Materialize, where we have like DBT models working that calculate these response rates in real time, and then a Lambda endpoint that directly hits the Materialize instance and serves it to the recruiting app. So as you can see, this is fairly similar to our previous implementation, and actually is quite a bit simpler, and especially simpler than the other experiments that we used. Yeah, so this allows us. We are also able to utilize indexing to increase our query speed, and we're currently using, I believe, 6 tables in Postgres to calculate the application the response rate. Could you go to the next slide? Thanks. Yeah. So this is just kind of like what it looks like in our front end for the recruiters. So they'll be able, when they log in the morning or whenever they do, they see what their response rate is, and they can click on respond to messages. They can go there, respond to the messages, and then within like a second, this will be updated back to reflect that they've responded to more applications. And as soon as they hit that threshold, they can start getting new leads. Yeah, so this is pretty important to the job seeker experience. Like, we want these recruiters who are responding to leads in a timely fashion and responding to all of their leads to get more volume. So this is really helps, and this really helps like reward responsive and engaged recruiters, which overall leads to a much better user experience. And that's like what we are really trying to cultivate at Vivian, which is like nurses feeling like their recruiters are like working with them and like quickly and not ignoring them and helping them find the best job placement as fast as possible. Yeah, and this has really helped enable us to improve that experience. So this implementation has been very helpful in terms of compatibility with our data team's existing capabilities. It's completely written in Python and SQL. So anyone on the team could really step in and work on this if it needed to. We also use DBT models. We were pretty able to port over the existing DBT models for this pretty easily, and not have to have a new configuration and trying to translate DBT models into Scala code and Flink is can be pretty challenging, especially if we want to maintain maintain the batch response rate as, say, a backup or something. And yeah, there's just a lot of support available for SQL and DBT, which has been helpful. And yeah, thank you. Yeah, I guess I kind of talked about this already. This has really improved the experience for nurses and recruiters. I was fishing around for a statistic to show you to say we're not getting any complaints, but it would just be a graph that basically dropped to 0 after we implemented this. And I want to emphasize again how this is a next generation improvement where you can drop from updating this rate from an hour to a second. It's like a very substantial improvement. And like, ultimately, like having better recruiters is what better recruiters draw like more candidates to the platform. And these kind of features and like real-time functionality like really get noticed by recruiters and pulls in new people. So I think this has been like a pretty helpful for helping improve user experience and the product and company overall.
All right. Well, thank you very much. Thank you very much, Max, for candidly sharing your use case and also your experience in using Materialize at Vivian Health. For the members of the audience, before we go into our chat and our Q&A, if you're interested to learn more, I would encourage you to, check us out. Either come to our website, materialize.com, or also, we have access to a free trial. You can feel free to register for a free trial. We do offer both a guided free trial experience if you want to leverage your own data, or we have a playground experience, a very simple click through that you can pretty much accomplish in under an hour and go through some of the examples that we provide with some of our demo data sets. So it's on materialize.com/register. I would encourage you to sign up and learn more. So with that, let's switch over to the chat window. And Chuck, maybe you want to come on and see if there's any questions that have come in?
Sure. Hi, I'm Chuck. I'm on the field engineering team. I work with Maxwell all the time, so this is fun to join. Couple of questions. So, streaming systems are notoriously difficult to deploy changes, e.g. with CI/CD. What's the experience for deploying changes in Materialize?
We actually ended up building a custom deploy script that builds a parallel system, and then we use like blue-green deployment to switch over to that one, and then once that's fixed, once that's working, we disable the old instance. And there's certainly room for improving that, and we'll improve it all the time. We recently started leveraging maintaining multiple connections to improve stability. We could also Chuck, the name escapes me of when you are slowly switch over from one to the other.
Oh, like Canary, yeah.
Yes. So that's like another thing we want to end up implementing. That was we just kind of built out our own blue-green deploy script for that.
Nice, amazing, and you all were sort of on the cutting edge of that. We were inspired by that script and recently deployed a change to the DBT adapter. So now it can automatically do those things, which is really great. So thank you, Maxwell, for helping with that.
Send me a link to the docs on that.
I will. So can you deploy Materialize in your own AWS account, or is it a managed service? So this is an easy one. Materialize is fully managed SaaS service. It allows us to, give you the highest quality of service with, we can focus on, one version of Materialize. We don't have to focus on supporting many different versions and many different environments. It allows us to really hone in on that quality of service. And focus on our engineering efforts on the platform itself, which is really nice. But yeah, the downside is, yes, you can't run it in your own AWS account. So think of us like, real-time data warehouse, the real-time sort of counterpart to a Snowflake. So Snowflake is analytical data warehouse, and then the real-time counterpart would be Materialize. Okay. Maxwell, have you gotten any feedback from the recruiters about these new real-time capabilities? Were they thrilled, or what was their experience like? Did you get any feedback directly from them?
I don't think we've got any direct feedback, but what I will say is people were complaining about this to their like customer service reps all the time, and like I was like, hey, I responded to all my applications. What's going on? Like, why am I not getting new leads? Why is it taking so long? And that we haven't gotten those at all. So yeah,
that's great. It's like
this kind of thing.
Yeah, if it works, nobody says anything. But if it doesn't work, then then the complaints come in and it becomes an issue. Yeah, that's funny.
That's just part and parcel of working in like back end engineering. You know, like you don't get a lot of like, you know. Yeah, I'd say that that is pretty important. That is pretty important. Like the fact that this was like it was bothering people enough to send messages and like try and find out what's going on, and then for that to stop completely. Yeah, that's a pretty big deal. I'm really proud that I was able to accomplish that.
Cool. Follow-up question. What SLA do we guarantee? That's something I don't have immediately offhand. We do have currently have a maintenance window. We are working to eliminate that maintenance window. But I would need to get the exact verbiage from the SLA to give a definitive answer on that. And the maintenance window today is specified as 2 hours. It's often minutes, but we do give ourselves a little bit of time just in case something happens during an upgrade.
All right. It doesn't look like there are any additional questions that have been entered into the chat. So thank you very much, Chuck, for following up on those questions. And thank you again to everyone who had attended today. We will be sending out the recording of our session shortly, within the next day. And of course, thank you so much, Max, for sharing your story today around Vivian Health. Really appreciate your collaboration here, not just for this particular webinar session, but also for all the experiences that you've had between Vivian Health and Materialize. So thank you everyone for your time today, and we look forward to seeing you again in a future webinar.
Thank you.
Yeah, thank you.